questions on any of the homework assignments? Careful. Who are we missing? Cody. Yes. Has anybody seen Cody today? Okay. There she is. All right, guys. Any questions over the homework? Questions over the homework assignments? All right, guys. What we're looking at today is the equation of all points that are a set distance from a given point. Yes, we're all familiar with this? Circles. Circles. Circles are the set equation that gives us a set of all points, the set distance, the radius, from the given point, the center. Now, and again, so we were going to do parabolas, but unfortunately, with me missing a day and we having a day off last week, I took parabolas out of the equation. That was actually a good joke. I didn't even mean to make it. Well, took parabolas out of the equation because parabolas are an equation. Yeah. So we're not going to do those. They weren't overly complicated, but it's going to be one less thing we look at. But the rest of what we're looking at today, circles, hyperbolas, and ellipses, are all in the category of conic sections. Now, when we look at circles, there's two standard forms of a circle. And I believe this is already put in your notes. You don't have to write this down. We have these here. The first one we have is x squared plus y squared is equal to r squared. And the other one is x minus h squared plus y minus k squared is equal to r squared. They're essentially the same equation. The only difference is the one on the left, the center's at 0, 0. So the value of h and k is 0. So x minus 0 is just going to be x squared. Same with y. The one on the right, we just put in the value of h and k. So the center's not 0, 0. It's not at the origin. And in the given equation, we'll have r squared, the radius squared. So whatever that number is, if we want to find the radius, we just have to take square root of it. And these are our standard forms. Questions on circles so far? So the first thing that we're going to be looking at is finding the equation of a circle. Now, we could start off with either form, but it's sometimes good to start off with our x minus h squared plus y minus k squared is equal to r squared. Because we could start off with this standard form of the equation, figure out our information, the values of h, k, and r, plug them in, and we have the equation. So the values of h and k is the center of the circle. So the center is the point h comma k. And if this hasn't been pointed out, I feel like I have pointed it out here. H is always going to be with x. H and x go together. Y and k go together. So whenever we talk about standard forms of equation, h and x, y and k, those are always going to be attached to each other. And it will be for what we see tomorrow when we talk about ellipses, those two are going to be together. When we talk about hyperbolas, those two are going to be together. When we talk about quadratics, those two were together, always. Now looking at the graph, we do have a center at -3, 1. So that's helpful because it tells us the value of h is -3. So we have x minus -3 squared plus y minus our k value is 1. So we have this here. And exactly, the negative and negative do make a positive. So we have x plus 3 squared plus y minus 1 squared is equal to r squared. So we need the radius. Did they give us the radius? No, not directly anyways. We know that the radius is the distance from the center of the circle to a point on the circle, yes? Now, if it was nice and we had a straight line on this plane where I could count the spaces, that would be nice. But they didn't give us that. However, we can find it by using a formula we had yesterday. The distance formula. And to find the radius, we're always going to go from the center of the circle to a point on the circle. Now, we could use 2 points on the circle that go through the center, the diameter. But if we use 2 endpoints on the circle, we have to cut that distance in half because the diameter is twice the radius, or the radius is half the diameter. So we would have to do that here. Would have to do it if we had the 2 diameters. But here, we have a center and a point on the circle. So we just need to plug that in. Now the order of x and y, we don't specifically have to put them in that order. So if we use -3 for our x first, so -3 minus 2 squared, it does not bound us. That 1, positive 1, our point from the center has to go first. We just need to put them x's with x's, y's with y's. Because flipping it, the main thing that it would do would be a sign change of what's inside the parentheses. But because whenever we square something, it makes it positive, so that sign change doesn't affect anything. So 3 minus 2, 1 minus -1. So we can say second square root. -3 minus 2 squared plus 1 minus -1 squared. Sure. 3 minus -2. Yep. So we can plug it in a calculator, let it do the work for us, and it's the square root of 29. Now we could do this in a graphing calculator or do it here. It really doesn't make a difference, one way or the other. We could have done it by hand and found out what the radical was and simplified it. But for circles, for the most part, simplifying this radical doesn't make a big difference. Any questions on how we found that the radius is the square root of 29? Well, we can plug it in. So it's the square root of 29, what? So we have x plus 3 squared plus y minus 1 squared. So it's the square root of 29 squared. Because the square root and square will cancel each other out. And that's it. That's the answer. That's the equation of this circle. Yeah, all we're trying to find is the equation. Yep, nope, that is solved. And that's also why I say we could reduce that radical if it was. Because if we had said it gave us the square root of 12, square root of 12 is 2 square root of 3. We could reduce it down to that. But since we're just finding the equation, not too much about the radius and center, well, I could reduce it to 2 square root of 3. But in this here, we have to square it which is going to get us back to 12. So if I left it as a square root of 12 squared, it comes out 12. But that's it for this here. Questions on this here? Let's look at 2a. Now y'all have space underneath, yes? So I would, if I was y'all, I would write this underneath it. I'm going to write a little bit to the side so that we can see it. Luckily I have technology so I can move things a lot easier than y'all can. With this here, I would still start off with x minus h squared plus y minus k squared is equal to r squared. And you can write this underneath. I'm going to write it to the side. I would still start with this here. Because we already have the center. The center is 0, 0. So that means we have x minus 0 squared plus y minus 0 squared. Which ends up being x squared plus y squared. Because x minus 0 is just x. So we have x squared. We can write it. And then we have y minus 0, which is just y squared. Now, we could have looked and said, okay, because the center is 0, 0, we'll use the other formula and go on that way. But using this one here with hk, no matter what the center is, we still get to the formula. I think this is a little bit easier instead of trying to keep, okay, which center do we have? Is it away from the origin or is it at the origin? If it's away from the origin, we use this. If it's at the origin, we use this. Why make it more complicated than it has to be? We use the 1, we plug the center in, okay, it's simplified away. We get this here. Now we just need to find the radius, yes. So the distance formula. This one here is even nicer than the one we did before. Because our two x values, well, one of them is 1, the other is 0. The y value is 5, and the other y value is well, 1 minus 0 is 1 squared. 5 minus 0, so 5 squared. Well, 1 squared is 1. And we could have plugged that in a calculator and it would have told us that it's square root of 26. And for a lot of these here, the graphing calculator can do it. I would kind of stay away from it because if it doesn't come out to be a nice radical, so square root of 16, square root of a perfect square, it's going to give you a decimal, and then we're having to approximate. But the nice thing with the 30xs is that it'll tell you it's the square root of 26. It'll nice number. We get the exact value. Okay, we can come back up here. Say this is equal to square root of 26 squared. Which just gives us 26. Questions? Do we need to see another example of one of these? Because we'll do one more. So let's look at this here. So we good with 2a? Yes? I'm going to erase all that. We'll look at 2b. X minus h squared plus y minus k squared is equal to the radius squared. Now this time the radius is not not the radius, but the center is not at 0, 0. It's at negative 1, 4. So we have x minus negative 1 plus y minus 4 is equal to our radius amount squared. Any questions on getting it this far? Now we just need to use the distance formula to find the radius. So our two x values are, well, -4 minus -1, plus our two y values are 6 minus 4. And again, at this point, we can type this into the calculator and let it do it for us. Four minus -1 squared, 6 minus 4. Here's 8 seconds. Square root -4 minus -1 squared plus, 6 minus 4. And we get square root of 13. Now the negative gives us a plus, so we have x plus 1 squared plus y minus 4 squared is equal to 13. Questions on either one of these here? All right. Let's look at the next problem. Write the equation and graph the circle. So we haven't done much graphing, and these here are actually quite nice. Now I'm not going to be, if we do have graphs on the homework, I'm not going to be a nitpick about the fact that part of your circle was 2 centimeters off of where it should be. I'm not going to do that. But when we look at this here, writing the equation of the circle is not that bad. Because we can start off with the equation that we've been starting off all of the problems with so far. X minus h squared plus y minus k squared is equal to the radius squared. Well, they were nice and they gave us the center is -2, -1. So we have x minus -2 squared plus y minus -1 squared is equal to. Don't they also give us the radius? So we can say it's equal to 9 squared. Really, we can simplify it a little bit and say x plus 2 squared plus y plus 1 squared is equal to 9 squared, which is 81. So that's the equation of the circle, yes? Now, when we started this lesson, I said we were covering the equation are all points that are equidistant from a given point. So, our given point, our center, is the point -2, -1. If we're to graph it, I can graph the center. With circles, I always graph the center first. And again, since it's a circle, it's all the points that are the equidistant, the radius from it, yes? And the radius is 9. So from here, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9 units going straight up. Well, apparently. And that'd be 1 point. We can go 9 units right and left. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can go 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can go 9 units down. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Yes. But again, like I said already, I'm not going to be counting off because you didn't get it exactly right. So just connect those 4 points. Questions on this here? We ready for the next one? So the first thing we'll do is find the equation. It's just plugging in the values. So we'd have x minus 0 squared plus y minus negative 6 squared is equal to 7 squared. So we plug in the center and the radius. Now, for the first part, x minus 0 squared, well, that's just going to be x squared plus y plus 6 squared is equal to 49. Zero, negative 6. This one's definitely going off the graph. So we can go 7 to the left and right, then we can go 7 up, and then we'd also go 7 down, and then we draw our circle. Questions on this here? Any questions on this here? We feel good with these here? Do we need to see another example of one of these? Write an equation of a circle given the endpoints of the diameter. Given the endpoints of the diameter. So, we need 2 things to find the equation of the circle. We need the radius, and we need the center. So guys, we need the radius and the center. Now, there's different ways we can start this problem. One of them is we can find the distance from the 2 endpoints, and then cut it in half, and then go from that to find the midpoint, because the center is going to be at the exact middle. However, it might be a little bit easier to find the midpoint of the 2 endpoints, because the midpoint of the 2 endpoints would be the center. So we can use these 2 points here. In our midpoint formula, we add the 2 x values together and divide by 2. We add the 2 y values together and divide by 2, and that will give us our center. So for us here, we're going to have 7 plus negative 1, and 6 plus negative 8. Well, 7 plus negative 1 is 6, and 6 divided by 2 is 3. Or we could plug 7 plus negative 1 over 2 into the calculator, and it'll tell us that it is 3. Which is So any questions on how we found the center?
Nope.
Now we can use the 2 endpoints to help us find the radius, but that would be the diameter, which we'd have to then divide it by 2. But since we found the center first, to find the radius, we can use the distance formula. And we'd have our x values and then our y values. And I can use 3, -1. I can use the point for the center. And that's one of the points I would use, because I would go from the center to one of the endpoints. It doesn't matter which one we pick, we just need to pick one of them. Do we want 7, 6, or -1, -8? So we'd get the square root of 65. So, guys, now the other one, as we could say 3 minus -1 squared plus -1 minus -8 squared. Because again, the radius is just the distance from the center to a point on the circle. Both of those points are on the circle, so we'll get the same measure. Questions on how we found the center and the radius? Now we just need to plug it into the equation. So it'd be x minus 3 squared plus y minus -1 squared is equal to square root of 65 squared. And once we simplify it, it's just going to be x minus 3 squared plus y plus 1 squared is equal to 65. That's it. Do we need to see another example of finding the equation given the endpoints? Find the center and the radius of the circle given the equation. Now we're not going to graph this one here, but we are going to find the center and radius. So this here, I think, is the last one that we'll look at. Now, looking at this here, the first step in this here is to get the x's together and the y's together, and then get the constant term on the other side. So here, our x terms are x squared and -8x. Plus, I'm going to leave a blank. Plus, positive y squared plus 12y plus blank minus 12 is equal to 0. Because for a circle, the equation of a circle is x minus h squared plus y minus k squared. And what both of those are is what we call a perfect square trinomial, a set of parentheses multiplied by itself. We've done these before. We did these in chapter 3, completing the square. We left 2 blanks here because I'm going to be able to rewrite this as a set of parentheses squared. Plus, for y, we're going to rewrite it as a set of parentheses squared. And the way that we do this, and the numbers that we have there, are given to us by the equation c is equal to b over 2 squared. where c is the middle term. So for this one here, -8 is our b. So c is equal to -8 over 2 squared. Now at this point here, we could plug it all into the calculator and do it that way, but it's good to at least write this first one out. -8 divided by 2 is -4. -4 squared is positive 16. So we'll add it in here. So we'll have plus 16. But if I add something to one side, I have to add it to the... Yep. So we put the blank in there so that we have this here. Now before we move on to y, we can go on and finish this here. Because we have x. Now what goes in here is whatever was inside the parentheses before we squared it. So x minus 4. X minus 4 squared, if we factored it out or expanded it out, is x squared minus 8x plus 16. We need to do this one more time. Because we have to do it for y. 12 over 2 squared. Now 12 divided by 2 is, and 6 squared is 36. So we add 36 here. You're good. We still have that minus 12 there. In the other set of parentheses, we will have y. And the number inside the parentheses before we squared it was 6. And since it's positive, we will have plus 6. Any questions on this so far? Yes, there's one last thing. It's that minus 12. Any question on this so far? We'll need to move it over. 16, 36, and 12. Because we do need the constant terms on the other side. Because according to the general formula, because here we have x minus 4 squared plus y plus 6 squared is equal to 64. The general formula is our x minus h squared plus y minus k squared is equal to the radius squared. We need all those constant terms on the other side. Oh. So what did it ask? Center and radius, yes? Now that we have this, so center radius. So when we look at this here, so we have x minus h, yes? In the equation we have x minus 4. The x's matches up, the negatives match up. So the value of h is 4. When we look at y's, the y's do match up inside the parentheses. But in the formula we have a minus instead of a plus. So it would be negative 6. Yes. We flip the signs on it. So since we had minus 4, the center is positive 4. In the equation it was plus 6, so it's going to be minus 6. Now the last piece is our radius. Well, the radius squared is 64. So we'd have to take the square root of 64, which is, so the, and we will go more in depth with radicals next semester. And we're going to actually get to see them in a better way than just a number times itself. But this is it. Questions on any of this here? Well, so the homework is a worksheet.